Modern software handles instant routing and complex chess moves with a speed that feels almost exactly like natural instinct. However, the machines do not possess natural instinct. They solve problems by treating every task as a navigational journey from a starting position to a specific target. To find the way, the AI maps every possible choice, every turn, every move, every variable into a branching structure called a decision tree. The challenge is the scale. In a complex problem, these trees grow into millions of potential paths, threatening to overwhelm the processor. To manage this volume, the computer relies on search algorithms, mathematical filters designed to find the optimal path without checking every single branch. The most basic method is uninformed search, often called blind search. Here, the AI knows the exit exists, but it has no clues where to find it. The algorithm operates by feel, testing every possible path step by step to see if it leads to the goal. The AI checks every branch on one level before moving to the next. It explores the entire decision space systematically. This brute force method is mathematically guaranteed to find the solution eventually. Given enough time to finish the search, while this works for simple puzzles, the math fails when it encounters the density of the real world. If a navigation app used a blind search to map a cross-country trip, it would treat a local driveway with the same importance as a major interstate. The result is an exponential explosion of data. The AI would attempt to calculate millions of irrelevant side streets and dead ends across the continent before finding the correct highway. Because these decision spaces are too vast for exhaustive checking, computer scientists use a more targeted approach. Informed search provides the AI with a directional compass, allowing it to estimate which paths are actually worth exploring. This compass is a heuristic, a mathematical rule of thumb that estimates the distance from any given point to the final target. Instead of checking every branch, the heuristic algorithm prioritizes nodes moving toward the target and ignores those heading away. Algorithms like A-star use this pruning method to navigate, skipping billions of irrelevant choices to focus on data that matters. By discarding bad options before they are ever fully calculated, the AI can find an optimal route in a fraction of a second. Chess engines use these guided strategies to evaluate board states, look deep into the tree of potential moves to find a winning line. Global logistics systems apply similar heuristics to organize the movement of thousands of shipping containers across complex port schedules. In manufacturing, these algorithms calculate the precise spatial coordinates required for robotic arms to move without colliding. Guided search also manages the signal timing and coordinate mapping for global positioning satellites. These algorithms provide the necessary filter for the high-density systems, ensuring that massive datasets remain navigable and actionable for human users. AI operates through a high-speed process of elimination, using mathematical logic to discard useless data before it ever reaches the screen. By combining systemic exploration with smart heuristics, computers can filter through billions of bad choices in a millisecond. Ultimately, artificial intelligence functions as a master navigator, using search to bridge the gap between its current state and its objective.